Welcome to Science Goes to the Movies, a look at the stories of science and how they change our culture. I'm Lisa Beth Kovitz. Today we're talking about infotainment and the weather. Joining us in studio we have Professor Jeremy Booth from CUNY's Department of Earth and Atmospheric Science, Dr. Veeshan Narinesingh, CUNY alum and now a postdoc at Princeton, and winging it in over the airways via Zoom, broadcast meteorologist and also a CCNY alum, Joe Rao. Welcome to the show.
Hello.
Thank you.
Thank you for having me. It's an honor to be here.
In Adam McKay's 2021 climate change allegory, Don't Look Up, when told a planet-killing comet is headed straight for Earth, Cate Blanchett's perky newscaster laughs off Jennifer Lawrence's terrified outburst, saying,
"Well, the handsome astronomer can come back anytime, but the yelling lady, not so much.
And Blanchett's newscaster might be the villain, but I felt for her. The yelling lady was ruining her show. But does show and entertainment need to be part of our weather broadcasts?
Dr. Harvey Leonard, a friend of mine, he told a story once about how with an impending big storm coming, that he needed to be in the weather center so that he could look at the very latest data for the 11 o'clock news. But the executive producer of the show said, "No, I don't think so. I prefer to have you outside in the elements. It's cold out there. We think we'd have more of a reaction if you were outside." And Harvey said, but if I'm outside, I won't be able to get the latest data and tell everybody how much snow we're going to get tomorrow with the big storm. Don't you prefer me to be inside looking at that, or prefer me, standing outside freezing my face off? And the producer said, I think it's better if you froze your face off.
How much of a role does entertainment have in understanding science?
Man, it's a huge thing, especially when you consider inspiring others. I grew up watching things like Magic School Bus and Bill Nye the Science Guy and all those shows with Professor Michio Kaku on them from City College. And it really inspired me to become a physicist. So I think, blurring those lines between entertainment and fun and learning experiences in science, that's really like the holy grail of science education and a good way to connect with people of all audiences,
The media and the government in Don't Look Up aggressively downplayed the danger of the approaching asteroid, as for many years, real-life media and government downplayed climate change. But now that it's on our doorstep, the media is jumping in with maps and graphs, and as noted by New York Times reporter Matt Ritschel, tons of gigantic, terrifying, entertaining, but misused scientific words. Does scientific terminology have a place in the weather report?
Definitely. We want to use the proper words sometimes, then other times we need to use words that people can relate to or are more familiar with. So for weather in New York City, the primary weather maker is an extratropical cyclone, but that's not a term you'll hear very often, right? You'll hear blizzard, nor'easter, because these are the terms we're more familiar with.
If you said extratropical cyclone to me in a weather report, I have the wrong channel, or because of the word tropical.
That's right, that's right. And in fact, a extratropical cyclone has nothing to do with a hurricane, which is a tropical cyclone. So it's really tricky.
Come on, guys.
It's just about the location where the storm takes place. But that terminology is not really used when we're talking about weather forecasts. So some technical terms stay out. Other technical terms get co-opted and used in different ways. So polar vortex used to be a term related only to the winds high up in the atmosphere over the North Pole. And then I think around 2014, a report came out, it might even have started in social media, referring to a polar vortex as the cold air that comes near the surface, down from Canada, makes it cold in the East Coast. And it stuck. And now polar vortex is in the lexicon.
And so a polar vortex has a very specific scientific meaning, but it's not polar air coming in when we hear it. It's got nothing to do with polar.
It is polar air, but it's the air up above the troposphere. And so it's in a part of the atmosphere where our planes typically don't fly, a part of the atmosphere where we don't feel that weather. Polar vortex that I learned in school, something totally different from the polar vortex we'll now see in the weather forecast.
The problem is, Lisa, is that whenever we get a shot of very cold air in this part of the country, automatically we hear, and the polar vortex, and in some cases, it's not the polar vortex. It might be some other mechanism that's driving that cold air into the region. But now it has gotten to the point in the lexicon where the term polar vortex automatically is associated with cold weather. And again, that's incorrect. But, what are you going to do?
And it's fun to say.
And it's fun to say.
Polar vortex.
Most importantly.
Veeshan, you want a piece of this before we move on?
Man, I would just say, the terminology can also be a barrier at the same time, right? So you want to be able to reach all kinds of audiences, especially, marginalized communities, for example. They're often left out. It's a harsh reality that, the educational opportunities is not the same for everyone. So the jargon and the scientific literacy, some people don't have access to that. So I think putting things in a way that everyone can understand is very important.
We recently had Stuart Firestein on the show, and we talked about nominal fallacies, or how naming something should be equal to explaining it. But broadcast weather reports are allotted only a fraction of the news hour. And when you add in our ever-shortening attention span, and also Dr. Narensingh's very important point that not everybody speaks the same exact language, do we need that sort of naming is explaining shortcut for people to understand when serious and dangerous weather is coming at them?
Well, I think the use of visual graphics has improved a lot, and that's pretty critical. You get a good visual, then you cut across a lot of barriers, and so that's one thing that's helpful. I'd say the issue with weather forecasts, a big issue, is that we're talking about probability, and how people think about probability is not always the same, and that's really a big next step. Communicating and helping everybody appreciate probabilities would be useful, not just for weather forecasts, but for a lot of things in life.
What happens if we don't trust our weather reporters, which we have for many years not trusted them as they talked about climate change? What happens when the weather is not well reported?
Yeah, I think, I'm sorry to just be sidetracked to this, but it comes back to an education issue and how you are interpreting the weather and how you take the weather report with a grain of salt. My sister doesn't know that when she looks at the weather report 7 days from now, it's, more inaccurate than what it is 3 days from now. But I know that because I study this stuff. So a lot of it has to do with educating the public on how we can, be skeptical in the right ways. Definitely, being over dramatic or sensationalism is a terrible thing in any sort of news outlet. But I think, educating the public in best ways to interpret it, this isn't a guaranteed. So you take with it what you will, and you understand it how you want and make your decisions based off that. But I think, at the end of the day, it's better to be safe than sorry because anything can happen,
Yeah, and also for New York City, we have this great case study of it where Hurricane Irene was forecast to come in and be pretty strong when it arrived at the city. But when it arrived at the city, it was weaker than forecast. And then the very next year was Sandy. And so in fact, responses of the public to Sandy were somewhat influenced by that exact event. So there is always this danger of what would be called a false positive, where you forecast that there's going to be something really bad, and then it's not there. I got it wrong. It's definitely not false positive.
Crying wolf.
Yeah, crying wolf. That's a good way to put it,
crying
right?
wolf, yeah.
And so, yeah, you want to be careful with how you're making the forecast.
Jimmy, you told me something about words we can't use, that tornado used to be a bad buzzword.
Yeah, that's right. So this is interesting, I think, counter example from what we're talking about with using buzzwords to increase the hype. In the 1920s, forecasts of tornadoes were really not good. They couldn't make a good forecast. And so the National Weather Service decided to just stop using the word tornado at all, because they realized that when it got said, people would respond to it by getting really scared or acting erratically. And so they said, well, since we're so bad at the forecast, just don't mention them. And it was still that way in the 40s, and it changed, and slowly but surely they changed the rule in the National Weather Service that you could use the term. But the movie Wizard of Oz, which has a tornado in it as a key thing, the tornado never gets mentioned as a tornado because that was still the accepted
It's a
thinking.
twister.
Yeah,
It's
yeah.
a twister.
It's a twister.
That's right. That's right. There was no using tornado. It was too extreme back then.
Early in the movie, before the world starts to end, the scientists are excited to pull out their orbital dynamics math out of mothballs, and they are having so much fun. So please, all of you guys, could you please tell me what is so fun about math?
You asked the perfect question for this guy. I'll just tell you that.
I think what's fun about math is that there's always a right answer. Now, in the math that we're doing for weather forecasting, that's not exactly true. But in the math that we learn to build up to that point, you can get to a right answer. And if you're tenacious, if you're just willing to work through it, you will solve your math problems. And I think everybody should reconsider how they think about math and perhaps embrace parts that they can do well and then challenge themselves to do a little bit more. But I do remember when I was taking graduate level math, the professor told me that the most important thing you need is a lot of paper and a big wastebasket.
Man, math to me is a form of empowerment for people. I feel like it often gets this bad stigma, but it's so useful in many contexts, and we don't even realize it. Like, obviously, for predicting the weather, we need math. But, for doing your taxes, you need math. Also, for say you got a job interview in Queens and you're traveling from the Bronx, you need math for that. So I think we need to get over this stigma, help people, really become empowered by math and use it as a strength. Because I think, from a physicist's point of view, math is just a tool that we use to understand what the universe is saying and the world around us.
And Joe, you're a communicator, but also a meteorologist. So how does math figure into your world?
I remember when I was working at this private forecasting service back in the 80s, that we actually had a couple of people from Brookhaven, or Stony Brook, I should say. Stony Brook was teaching meteorology courses. These people who were coming to us for a job, they knew everything up and down in terms of the thermodynamics and in terms of the equations and whatever, but they never plotted a weather map. They never got into forecasting. They just thought that they'd automatically be able to get a job. And we said, no, you can't. I mean, you got the degree, but you got to have the knowledge. You have to have the experience of being able to forecast for an impending storm.
I was that person Joe mentioned. So I went into an atmospheric science PhD program with a master's in applied math. And the only class that I got below an A in was the weather forecasting class. Same thing. It's just a different part of it. And it's an element that involves a bit more combination of memorization and then making intuition. And you get there just with the experience.
Professor Booth and Professor Narinesingh, you guys both use geofluid dynamics to what? Predict the weather? How? Again, these words. What do these words mean?
Yes, so first of all, it's not professor quite yet, so we'll see. We'll see how that works out. But yeah, geophysical fluid dynamics, right? It sounds really scary and crazy, huh? But it's not that bad actually. So let's break it down. So fluid dynamics, we think about fluids moving around, right? Water is an example of fluid. The atmosphere is an example of a fluid. So
River.
fluid dynamics,
Yes.
a river.
Going down.
The atmosphere is a fluid?
Yes, you didn't know that?
part's-
I
yep.
did not. Nobody tells me
Oh my
anything.
gosh, yeah. Well,
No, that part is the tricky part. Yeah, because once we get to the air, which we don't see, thinking of it as behaving kind of in a similar manner as the ocean is a really tricky part. But in fact, it is. It's the molecules that are moving around lead to wave motion, waves in the atmosphere and the ocean that have similar behavior.
Yep. And to take it a step further, now that geophysical part, this is fluid dynamics in a geophysical context. So, planets, moons, stars even are all part of geophysical fluid dynamics.
And after you say it twice, you just shorten it to GFD.
GFD.
And you don't have to say it anymore. It's just GFD, all of us.
That works better for me.
Yeah.
But that also feeds into this idea that I'm realizing it's not just how many variables, but the location of the variables are so broad.
Yeah.
That's true. That's right. Yeah. And you're thinking now about lat and lon direction, height, but then time. So it's a 4-dimensional problem that you're going to solve.
So really, the idea that we could do 5 days of prediction is actually quite extraordinary.
That's right. And counter or addition point to earlier statements about math, the models, the equations that are solved for these, that's all math, right? And then the solving of that is a combination of computer science and mathematics.
You're actually playing a chess game. The chess game is being played between the short-term computer models and the actual atmosphere. Let's say you have a big storm hitting the West Coast, which eventually may bring a big storm to us here in the East. But before that big storm in the West hits, there's another storm that's moving through the Ohio Valley and moving into the eastern United States. What happens ultimately with that storm hitting the West Coast will be, what will the storm that's hitting the northeastern United States do?
That's right. And actually so the tape, the reel going around is kind of indicative of a snapshot of weather if we're looking at across North America. So it's like, this could be the West Coast over here, and this could be the East Coast over here. And what Joe's saying is this storm over here on the East Coast and the wiggles on this side are going to impact how these wiggles, when they arrive, act.
Right.
Luckily, this one's stationary, so I got this forecast figured out.
Sci-fi's new movie, The Ark, is about humans evacuating to another planet. So is the speculative documentary Evacuate Earth, and also the movie Oblivion, and Io, and Red Planet, and Interstellar, and After Earth. We spend a lot of time fantasizing about fictional extreme weather evacuation, but we rarely talk about it in real life. Jimmy, should evacuation procedures be part of the weather broadcast?
If we're talking about evacuating from one part of the Earth to the other, yes. Yes. I think that once a storm, like a hurricane, gets close enough to a region, 2 days out perhaps from impact of the eye wall, we should think about helping people evacuate. And this is one of those things that's hard to plan for, but needs to become something that is involved in our FEMA process for thinking about moving people out of harm's way.
Joe, as a communicator of this information, do you think that this is information that could have been put into your weather broadcasts?
We should have had some kind of a plan in place when Sandy hit, and we had all of that flooding occurring down across the coastlines of Staten Island, Brooklyn, Queens, and portions of Long Island. And people just, they didn't know what to do.
Right, so.
But the infrastructure of New York City is old. And every time we get a major rainstorm that drops a copious amount of rain and floods out some city streets or some major roadways, the politicians always come out and say, well, first of all, the politicians blame the weather forecasters. We saw that with Ida a couple of years ago. And I know for a fact that more than a few of us on television or in the communications field warned everybody that Ida was going to do just what it did. It flooded out. But then the politicians say, well, we weren't warned. But the bottom line of it is that they flood and nobody hardly does anything about it. A lot of places in the city are still running on sewer systems and flooding situations that go back 50, 60, 70 years and just simply cannot handle the tremendous amounts of rain that are now falling in lieu of climate change and global warming that we're seeing now.
I have a map from 1950 hanging in my house because I'm in a geology department, so we have old maps, and all the bridges are the same. And I look at it all the time. All right, they're not named the same, right? Some of the bridge names changed, but just the fact that we have so many more people in the city, and yet our bridges, we're not increasing them. If only there was like a politician who had a plan called the Great Rebuild or something.
The infrastructure bill.
Yeah, that.
Yeah, the big infrastructure bill.
Yeah, I mean, the point of that is exactly what we need.
Safety.
Yeah, it's infrastructure, right?
Yep. Don't Look Up is a terrifying and great allegory of the media and government's role in reporting climate change. In real life, what do you, as research scientists, suggest for us in the media to improve and avoid, death and destruction.
Growing up in New York my whole life, I think probably at the local level, we do a pretty good job in communicating. I mean, there's these forecast busts and so on and so forth, but I mean, that's a very regular thing when it comes to meteorology in the first place. I think furthermore, though, this point about, educational access and having people have the right knowledge and tools to be able to assess a weather forecast and, know how seriously to take it. I think that's probably the most important thing, is educating people to know this information.
Yeah, yeah. And part of what we're doing at CCNY is helping people understand the difference between weather and climate. So weather is our short time scales. Climate is our longer time scales. We say climate is what you expect and weather is what you get. Or climate is what you have in your closet and weather is what you're going to wear on a given day. When communicating about climate change, especially in this region, what I always try and do is separate our understanding of how things will change in summer and how things will change in winter. So in summertime, things are getting warmer and the number of warm days are increasing and will continue to increase. And the hottest days will be hotter than they are now. And those changes, we have much less uncertainty about than our uncertainty in what's happening in winter. And those things that are happening in summer are definitely more dangerous when you look at the fact that there's NYCHA housing where the air conditioning isn't working great still, right? Yeah. And so if we want to tell people about climate change and say, what's the next step? Think summer is going to get more extreme and we need to prepare for it. Winter, it's already pretty weird and it's gonna continue kind of being this way for a while. Maybe 50 years from now, we see winters like 2023 where we don't have snow all through January and February. Maybe that starts happening a lot more frequently about 30 years from now. But between now and 30 years from now, every summer is going to have days that are as hot as usual or hotter. Wow. And that's really where New York City can start planning for climate change.
And we absolutely cannot confuse that kind of prediction with the fallibility of the 10-day forecast or what's going to happen next month.
Correct. That's right. That's a different element, different types of physics involved, and our understanding of the long-term changes in summer are grounded not in numerical models only, but in theory that we rely on every day.
It's actually, if you go back into the 1970s and look at the long-term records at the National Weather Service site at Central Park at Belvedere Castle, you'll find that on average during the winter back then, we were getting about 23 or 24 inches of snow each winter season. Now, if you look at those same records for now, the 50 years later, the amount of snow is up to 30 inches. We've actually increased in the long-term averages by 5 or 6 inches of snow. And some people look at that and say, well, they say global warming. How come we're getting more snow now than we did 50 years ago? It's all nonsense. No, it's not all nonsense. The reason why the snowfall has increased over the past 50 years here in the tri-state area is that as the atmosphere warms, it has a greater capacity to hold moisture. Well, with more moisture now, whenever there's a shot of cold air coming in, what happens? More moisture, more snowfall.
So talking about the analogy with the movie and a storm or an asteroid coming into one area, if we think about a hurricane on a one-day forecast timescale, for instance, coming in somewhere on the East Coast, maybe not New York City, maybe farther south, but on a one-day forecast, we're pretty good about knowing where it's coming and it's bearing down, right? That sort of mindset and what's going to happen there is something where we need more communication about how to deal with it. And what's kind of interesting is that a hurricane warning at those timescales is actually a little bit less scary than a tornado warning at a similar timescale where we don't know where the tornado is coming. So it's funny to say it, but sometimes when you know what the doom is, there's a little bit different mindset about it. With a hurricane, with a tornado, you can have an area that's in a tornado warning, but you have no idea where that tornado will hit exactly.
Right.
And I just the other day heard two people talking. They must live down in the South where both happened, and they were saying, "Oh, I'd much rather being in a hurricane warning than a tornado warning," and it's just a different aspect for this.
And that's all based on, is that all based on the mathematical variables of tornadoes versus hurricanes?
It's based on tornadoes being much shorter lived, and our observations of them not being as well documented, and also they're much more difficult to predict because other factors cause them to change a lot more than a hurricane, which is bigger.
Let's just, what is that thing from Fiddler on the Roof? May God bless and keep the tornadoes and the hurricanes far away from us.
That's right. That's right. That's right.
So I'm so sorry, guys. We are so out of time. Thank you so much for joining us. Joe, thanks for winging in for us.
Thank you. Thanks for having us.
Thanks
It was
for having
great.
us.
Yeah,
Appreciate
enjoyed
it.
it.